Hey guys, let us start with question number 43. In question number 43, we have to find limit n tending to infinity un upon un plus 1, and it is given that un is equal to 2 into 5 into 8 into 11 dash 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 up to 3n minus 1. In denominator it is given that 1 into 5 into n into 13 dash 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 up to 4n minus 3. So this is our nth term. So we can find its n plus 1th term just by replacing n by n plus 1. So this becomes dash dash dash. So this is 3n minus 1 into, just replace n by n plus 1, so it becomes 3n plus 2. And in denominator it becomes 1 into 5 into 9 into 13 dash 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 4n minus 3 into 4n plus 1. Just replace n by n plus 1. So let L is equal we have to find the limit n tending to infinity un upon un plus 1. So take the ratio and take its limit un upon un plus 1. So this can be written as 2 into 5 into limit n tending to infinity 2 into 5 into 8 into 11 dash 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 3n minus 1. In denominator 1 into 5 into 9 into 13 dash 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 up to 4n minus 3 into 1 into 5 into 9 into 13 dash 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 4n minus 3 into 4n plus 1. In denominator it is 2 into 5 into 8 into 11 dash 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 3n minus 1 into 3n plus 2. So this term get cancelled, this term is cancelled with this. So only remaining part is limit n tending to infinity 4n plus 1 upon 3n plus 2. So this can be written as limit n tending to infinity 4 plus 1 by n upon 3 plus 2 by n. Just substitute the value. So this becomes limit of 4 plus so this becomes 4 plus 0 plus 3 plus 0. So this is 4 by 3. So 4 by 3 is correct answer. Next question, that is question number 44. Question number 44 is question number 44. We have to check the convergence of this power series, where power series is 1 plus x upon 1 factorial plus x square upon 2 factorial plus x cube upon 3 factorial dash 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 plus x raised to the n upon n factorial. We know that if an x raised to the n is any given power series, then by using ratio test we can find its limit, and its limit is limit n tending to infinity. If this is the nth term, then L is equal to limit n tending to infinity un upon un plus 1. If L is greater than 1, then series is convergent. If L is less than 1, then series is divergent. And for L is equal to 1, test is inconclusive. In this problem we have to find all such x for which this series is convergent. Here nth term is x raised to the n upon n factorial, and n plus 1th term is x raised to the n plus 1 upon n plus 1 factorial. Just replace n by n plus 1. So by ratio test this becomes L is equal to limit n tending to infinity x raised to the n upon n factorial into n plus 1 factorial upon x raised to the n plus 1. So this can be written as limit n tending to infinity x raised to the n upon x raised to the n into x into n plus 1 factorial can be written as n factorial into n plus 1, and in denominator it is n factorial. So n factorial get cancel, x raised to the n, x raised to the n get cancel. So this is equal to limit n tending to infinity n plus 1 upon x. This limit is infinity, and we know that infinity is greater than 1. So this series is convergent for all x. because here limit is independent on x, so this series is convergent for all x. Next question, that is question number 45. In question number 45 we have to find the x for which this series is convergent. So this series can be written as 3x plus 3x square and dash dash dash. This is geometric series with common ratio r is equal to 3x. We know that geometric series is convergent if r is less than 1. So this series is convergent if 3x is less than 1. So this implies x is less than 1 by 3. So for x is equal to 1 by 3, this series is convergent. The next question, that is question number 46, is it is given that power is 1 plus 2x plus 3x square plus dash 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 plus n plus 1 into x raised to the n and so on, where x lies between 0 to 1. In this problem we have to find here x is given, we have to find this series is convergent or divergent for x lies between 0 to 1. Here nth term is n plus 1 into n plus 1 into x raised to the n. So n plus 1th term becomes n plus 2 into x raised to the n plus 1. So just find limit L is equal to limit n tending to infinity un upon un plus 1. So this becomes limit n tending to infinity un is n plus 1 into x raised to the n upon n plus 2 into x raised to the n plus 1. So this can be written as limit n tending to infinity 1 plus 1 by n into x raised to the n upon 1 plus 2 by n into x raised to the n into x. So x raised to the n, x raised to the n get cancelled. So this becomes 1 by x. And if x is lies between 0 to 1, this value is always greater than 1. So